what we're going to work on today is this activity 11. And the reason I've got two Arduinos here is that we're going to get these to talk to each other over the I2C protocol. So that means you're going to need to group up with somebody else. And we're basically, or if you have extra Arduinos, but I think it's easier to work in a group or work in pairs. So we need 2 Arduinos. We need 2 USBs. You can do this with a single computer. In fact, what I have set up is I have both of these Arduinos hooked up to my laptop, but it's probably a little bit easier if you have one computer set up to be the one you're programming the master Arduino, and the other one to be the one you're programming the slave Arduino. That is all you have to do. Is you actually just have to make sure that you have the right port selected. So if I have 2 Arduinos plugged into the same computer, what you'll see is so if I go down to my ports here, I can see COM5 and COM8. One of those is one of the Arduinos and the other is the other one. So what we actually want to do, and if you have an oscilloscope available to you, you can actually connect to the data and clock lines and display that on the scope as you're doing this. That way you can actually watch the data transmissions, but you don't need that to actually do this. So I want to pick one of these Arduinos to be the master and the other to be the slave. It doesn't really matter. I just want to make sure one is one and one is the other, and I don't have 2 masters or 2 slaves, because that's not going to work. So we're going to have a separate program in each part for the master and a separate program for the slave, because they need to do different things. But first, we need to hook these up together so they can actually talk to each other. So the first thing that I want to do is I want to connect the ground to the ground. Yes. Oh, right. Yeah. Sorry. Yep. Someone just reminded me that I was still sharing my screen and not. So, like I said, the first thing we want to do is connect the ground to the ground. Right. And that just makes sure these Arduinos are operating on the same 0 level. So you can see that I'm plugged into the ground here, indicated by the white, and the ground here. Okay. The next thing that we want to do is connect the data and the clock lines. So I want to connect, so the data and the clock lines are down here in the corner, pins down here in the corner, pins 20 and 21. So I want clock to clock. So I'm going to use orange here for the clock, and I'll use yellow for the data. Okay. So that's it as far as connecting these together. One thing that you can do is you can connect the 5 volt of one of these Arduinos to the VIN of the other Arduino. And what that'll do for you is it'll let you power the Arduino from a single Arduino, so I don't have to have them both plugged into the USB at the same time. But if I do have 2 computers or 2 USBs, I don't need to do that. So there's basically two things that we're going to try and do here. The first thing we're going to do is we're going to basically program the master to just ask for 5 bytes from the slave, and the slave is just going to respond with a set response every single time. So if you go through the activity, it steps you through all of this, and like as usual, there's sample code, but I will just first walk you through the slave code here. So obviously the first thing that we need to do is we need to include the write library. So we want to include wire. Okay, and then in the setup, we just need 2 lines. We need wire.begin, which is going to initialize the I2C bus. And in this case, we want to put a number inside the argument here. I'm picking 16 because this is the slave device. The number in there is going to be the address of the slave device. However, if I didn't have anything on there, that means I'm telling the Arduino that I want it to be the master device. So what I'm doing here is basically setting up that I want this Arduino to be on the I2C bus as a slave device with address 16. The only other thing I need in my startup is I need this wire on request. And what this does is basically tells the program when you get a read request from a master device, execute the function that's in the parentheses here. And in this case, I've just called it request event. But you then need to go write that actual function in the program. And then the loop is super simple because we don't want this Arduino to actually do anything except respond to a read request. So it's just, all I did was put in a super short delay in here. Arguably, that's not even really necessary, but this is basically just going to sit here waiting for a read request. But we need to actually program the function that does that. So this function, I can give it whatever name I want, but it has to be a void function and it has to have no arguments. So like I said, I just called it request event in this case. And then whenever this device sees one of those read transmissions with address 16, it's going to do whatever I put in this function. Right now, all I have it doing is basically writing the string hello, so these 5 bytes onto the I2C bus after it receives that. You can see here commented out, here's a few other options. So once you get this first part working, you should play around with trying to send other stuff, you know, just so you can see, oh, this is going to respond with whatever I tell it here. And in particular, this bottom set here is I'm sending numbers instead of characters. But remember, the only thing that gets transmitted is a byte. So the master device, whatever is listening on the other end, has no way of telling, oh, was I sending a character or was I sending, you know, a integer number? It's just going to see the byte. And on the other end, you have to assume that it's a certain type and handle it that way. So if you look at these strings, you'll see that each one of them is 5 characters long. It's going to be 5 bytes long, because on the master, I'm going to program it to read 5 bytes from the slave device. So in this case, I can also, instead of doing a single write with 5 characters long, I can have 5 individual writes where I'm sending a single number. So what this will actually do is it'll send the byte, the binary value for 49, and then 32, then 50, then 32 again, and then 51. And you could in theory send anything else, but I picked these particular numbers because these are the ASCII values for 1 space, 2 space, and then 3. So that means when I have this version where I've uncommented this section of code, what I should see this respond with on the master is 1 space, 2 space, 3. But so this is all you need. So I'm going to select one of my Arduinos. So I'm going to have this one on COM port 5, and then I'm going to upload this code. Okay. So now this code is running on one of my Arduinos. It's not really doing anything because it's just sitting there waiting for this read request, which isn't going to happen until I program the master Arduino to actually send it. So now let's look at that code. All right. So again, first thing we got to do is we got to include the library. And in our setup, it's almost even simpler, right? We're going to call wire.begin again, but in this case, we put no number inside the parentheses, which tells this Arduino that I want you to act as the master device. And then we're going to initialize the serial port because I'm going to want it to print out whatever it receives back from the Arduino to the serial port so that I can see what it's doing. And in this case, because it's creating the reads and writes, I don't need those request event functions because the master device should never see a read or write. It only it will initiate the communications and then it'll see the data from the other devices. Okay, so in my loop is where I'm actually going to do the read request, and it's where I'm going to display whatever I get back. So I'm just going to create a temporary variable that's a character because I'm expecting to get a character back from the other Arduino. And I'm just calling it C. And this is just where I'm going to store each byte of data as I get it back. So how do I actually do this read request? Well, it's pretty simple. I use this function here, wire.requestFrom. And this function is going to have 2 arguments in it. The first one is the address that I'm requesting data from. And if you remember, I set the address of the other Arduino to 16, so I want this to match. And then I'm going to request 5 bytes of data. Sorry, my comment had an error there. So this is going to send that read request, and then it's basically going to read 5 bytes worth of data. Where that data is going to go is an internal variable, a buffer that's part of this library. So I have to get that data out of that buffer before I can actually do that. So how you do that is I'm going to use a while loop here. And what I'm going to use is this wire.available. This is going to tell me the number of bytes that are in that buffer. So right after I do the read, this will first return a 5. So I'll get while 5. And basically any number other than 0 is going to evaluate to true. So this loop will continue to run until there are no bytes left in the buffer. So inside this loop, I'm going to call wire.read. And what that does is that just returns the value of the next byte in that buffer. So in this case, it'll return the first time through the loop, it'll return that first byte into C. After it returns it, it deletes it out of the buffer. So once I did this once, there will only be 4 bytes in the buffer. And then I'm just sticking it temporarily in my variable C, and then I'm going to print C to the serial port so I can actually see what it's doing. So that's going to run through 5 times because I'm reading 5 bytes in. And once I've read all of the bytes out of the buffer, when I get up to the top of my while loop, there will be 0 bytes available. That will evaluate as a false. It will exit from my while loop, and then it will go down here. The next thing that it's going to do is it's just going to print a new line so that I can see, so that the variables aren't, right on top of each other. And then it's just going to wait a second, and that's mainly so that it doesn't continuously spam the serial monitor. So I want to pick my other COM port for this. So the other one was COM 5. So this one I want to be COM 8. I'm going to upload this to the Arduino. Okay, so there's really no way to tell that it's actually doing something until I open the serial monitor. And if I share that serial monitor with you guys, you can see it's basically printing out hello, hello, hello. So one thing I can do without altering the code on my master Arduino, I can go to my slave code, and remember I had those other options of replies. I can comment out the hello, and I can uncomment one of the other ones. And if I upload that, you'll see the reply change here. So if I change it to the wire.write snail, I get that. And in particular, if I switch to the version with the numbers and I upload that, remember I was sending like 49, 32, 50, 32, 51, but I'm going to interpret those as the ASCII value. So I get 1 space, 2 space, 3 space. So that's what you guys want to do for the first part. The second part, we want to get a little bit more complicated. And again, the activity steps you through all of this, so you don't have to frantically try and scramble. What we're going to do is we're going to send, on this case, we're going to do a write operation followed by a read operation. So what we're going to do is we're going to send 2 numbers and a byte that indicates the type of math operation I want the slave to do. So I'm going to send it 2 numbers, and then I'm either going to have it add or multiply those 2 numbers together. After I send that as a write, I'm going to do a read operation where I'm going to basically request the result. So if I open that code for you guys, and one thing to note is I'm going to have to close my my hello code, because those 2 Arduino windows are already using the serial port. So I need to close those other windows so that I can select the serial ports. Okay, so now let's look at the slave code for this math sketch. So it's going to be similar, but a little bit different. Again, I need to include the library, but I want to create the variables that I'm going to actually use, right? So I know I'm going to get a number. In this case, I've just called it A. I'm going to get an operation. I've called it op or OP this time, and I'm going to get a second number called B, right? And I'm going to declare all of these as bytes just to make sure that I don't have these as larger, like, so a regular integer or something like that is actually bigger than a byte. So because I want to just work in bytes, I'm actually going to declare these all byte type. And then I'm going to have a variable where I'm going to stick the result of either the addition or multiplication. I'm declaring these up at the top because I want them to be global variables, because I'm going to need to use them in a few different functions. So if I declare them outside of the function, all of my program can see them and use them. So in my setup, it's similar. I have my wire begin with the address. I'm initializing a serial port again this time on the slave. That way I can actually output the values it receives in case I wanted to troubleshoot. I have my original on request event. Well, it's going to be a different function this time. And then I'm going to have this wire on receive. And this is very similar to the on request, except this is how the program reacts to getting a write command instead of a read. Again, the loop does nothing. I don't want the loop to do anything. So first, let's look at this receive event. So when it gets a write, I'm going to expect 3 bytes. So in this case, I'm just going to call wire.read, and it's going to read the values off of the buffer. There's no request from this time, because remember, this is happening because I got a write transmission. So I'm going to read the first byte. I'm going to stick it in A. I'm going to read the second byte and stick it in op, my operation, and I'll read the third byte and stick it in B. And I'm going to print all 3 of those out in case I wanted to troubleshoot, so that I can make sure that I'm actually receiving the values that I'm sending on the one end. So all that's going to happen on the right is it's going to get 3 bytes in, and it's going to stick them in those variables. So then I'm going to do the actual math and the return in response to the read. So I basically just have a very simple series of if statements. So I have this first one is basically so that I actually have a response if I got a read function before a write. So this is what's going to happen based on my default value for op. It's just going to send back a 0. If my op byte equals 1, I'm going to say that means I want it to do an addition. So I'm going to set the result equal to A plus B. Pretty simple, right? If the op byte is equal to 2, I'm going to multiply the 2 values together and set result equal to that. And then I'm just going to write that single byte back. So again, that's all done. So let me upload it. I'll actually switch them this time, but it doesn't matter because they're connected the same way. So COM port 8, I'm going to upload. Okay, so now that's running. And now I will switch to the master code. Okay, So fairly similar in the setup. In fact, the setup in the declarations is the same. I call the library, I call wire begin to tell the device that I want it to be the master on the I2C bus, and then I'm going to create a serial port so I can output the values. Inside of my loop, I'm going to have my temporary variable. I've changed it to an integer this time because I'm expecting a number to get sent back instead of a character. And then I have my two values for A and B that I'm just going to hard code this time. So if I wanted to change it, I can change these. Right now, I just have them set into 3 and 8. Now, the way that the write operation works is a little bit more complicated than the read operation. You need to first call wire.begin transmission, and the argument there is, again, the address of the device that you're talking to. So this tells the Arduino that I'm going to do an I2C operation to device 16. I'm going to do a write operation to this. Then what I'm going to do is I'm going to call wire.write a bunch of times, or I could put like a string of characters. So in this, and what that's going to do is it's basically going to set up these 3 bytes to get transmitted, but they're not going to get transmitted yet. So you can see I'm going to first queue up the value of A, and then I'm going to queue up a 1, because remember, that's what I decided indicates an addition, and then I'm going to queue up B. Finally, I will call wire.end transmission. And what that'll do is basically send all of the bytes that I queued up since this begin, and it'll send those as a write. So this whole section right here is all that's required. All of that is required to send it as a write. And then after I've done that, I'm going to do the read request. And this is exactly like it was in the first part, except this time I only want a single byte back. So I'm going to do the request from, that'll copy it to the buffer. I only need to call read once because it's a single byte. I'll read it into the integer C this time, because remember, I'm expecting a number and I'll print it out. I'll just wait a second, and then I'll basically do the exact same thing, except this time I'm going to call the middle byte as a 2, because that's the value I picked as a multiplication. So if I upload this to the Arduino, I have forgotten which port I picked for the other one. So I'm just going to quickly cheat and look at the other one. Okay, the other one was COM8. So I need this one to be COM5. And now we'll upload to the Arduino. And it's running. And if I open the serial monitor and I share that with you guys, and you can see it's basically alternating 11 and 24, right? Because it's adding 8 and 3 and then multiplying 8 and 3. And if I wanted to, I could go in and change the 2 numbers that I'm using. And I'll do that now. So I'll change my 3. I'll change my 3 to a 7. And I don't need to modify the code on the slave, because all I'm doing is changing the number. And you'll see that now it's adding 7 and 5 and multiplying 7 and 5. So one thing to remember, though, is because this is a single byte, I'm sort of limited to values between 0 and 255. But this is basically how you're going to do every sort of operation where you're communicating on an I2C with an I2C device. You're going to do some sort of write first. Usually that's telling the device what value you want to get back from it. So a lot of your sensors will be measuring multiple things. For example, it could be a real-time clock. And so obviously you can have minutes, seconds, hours. It may have dates. So you'll write a value that first says, hey, on the next read, I want you to give me the day. So you do a write and then you do a read. And that's sort of in general how you're going to interact with these devices. So that's it for the activity. You guys should try and get that working.